Wow, this is like a common group of people.
Yeah, long time no see.
Yeah, really. So we'll let people join. I put together kind of a mind map of a manual mind map of topics and where they're being covered. And so I was thinking, maybe we could take a look at kind of the big picture where things are being covered. I've got a few holes, a few suggested topics, and we can kind of pick up where we were last week and um, figure out the most important thing to work on next. We'll give people a little while to join. Um, I'm going to go ahead and share the picture I drew. We'll wait, and we'll wait for opens and stuff. I'm not gonna, I'm not trying to jump the gun too much, but I thought maybe I would seed um, the thoughts while we
Good
wait.
afternoon, everyone.
Good afternoon. How are you doing? Let's see. I'm trying to get, so I installed the Zoom app to try to make things go smoother, and it isn't doing what I want. So I don't think it helped me. Let's see. Oh, there we go. No? Oh, I don't know what's going on. I think I learned my lesson. Don't use the browser version. Okay, well, we'll give people a while to join. So we got this, and then there's been some feedback from the OCP folks on the submission we've got. And Russ, I know you're new, but my understanding was that if it's not a specification, if I'm talking to Alicia, that there's like this 2 week window, and at the end of the 2 week window, it was kind of automatically approved. I've got stuff to fix. The review period ended yesterday, but Alicia's out, so I'm not sure what to do other than to just, someone's got to click something to move it forward in the process.
Yeah, so this was presented to the steering committee. That's the start of the 2 weeks, yeah?
Well, so this one doesn't have to go to the giant steering committee, but it went to the hardware management steering committee.
Okay, what was the submission? I'll look it up.
There are
I'll see if
three
I
of
can
them.
look it up.
Yeah, there are three of them. There's a white, they're all white paper reviews, and
Okay.
there's OCP fault management infrastructure requirements. I'll see if I can paste them into the chat. If I can get the chat to work. I'm really not liking this new interface. Okay, for Zoom. I should have used the browser. Okay, that's the first one in the chat. Then the next one is this, the OCP fleet memory fault management. And the third one is a poison one.
Okay.
So yeah, I mean, yeah, I just don't, the process, this is my first time taking it through the process, this new process. And so if you have some suggestions.
Let me see if I can just look them up right now. I don't have access to everything that's in the workflow, but I think I reviewed at least one of those white papers.
Oh, cool. Okay, well, and if you can guide, if you can even just give me a hint as to, do I need to do something, or am I still waiting on Alicia to click, next in, some process? That'd be great. Okay. Well, and so I don't know if we're going to get your guest here today. I'll make sure he knows. Okay. Well, so while we wait for other folks to show up, what I did was just tried to map out the different things that I think are going on. And so each circle here is an effort, and so we've got this effort, which is kind of a central coordinating effort. We got fleet memory fault management, RAS API, OCP GPU RAS, and OCP CPU debug. And the GPU and CPU debug are not like fully open groups at the present time. And so cool. I got your email. I'm sorry I haven't gotten back to you. I'm working on it to figure out what to do, but I'm not in control of those groups, so I'm not sure how people get in them. So,
Okay, much appreciated.
I'm asking around.
Thanks for that.
And so then the RAS API is an open group, but requires a contributor license agreement because we're working on a spec. And so this is just standard practice within OCP to protect specs. So everyone is welcome. You just have to sign something saying that you're going to, like contribute to the spec, as per OCP rules. It's nothing, nothing real exotic there.
Drew,
Oh,
is that something that was sent out? I just want to make sure I didn't miss it when I was, doing some modifications.
the RAS API thing?
Yeah. You mentioned there's another thing to sign.
Yeah. If you look, basically what happens is you sign the CLA, and then when OCP tells Yogesh and I that you have signed it, we add you to the meeting. And so let me find.
I think it's a company wide, right?
Yeah.
It's not an individual person.
Yeah, it's a company sign, but
Yeah.
but the deal is that it may not be Yogesh anymore, but the deal is that we have to hear from OCP that OCP has your signed CLA from your company or.
So, okay, we have signed it, so you should be able to
Okay, good.
request for that.
Yeah, thanks. Because I know I think
yeah.
you forwarded the meeting to me, so I was
Right.
Yeah, Meta has signed and you're okay.
Okay, thank you.
So, but other companies, if you're interested, I'll send you a link to the OCP webpage for it, and I'll put that in the chat. And then if your company elects to sign the CLA, we would absolutely welcome you. Okay. So, and then fleet memory is completely open, so you can just show up. And so what I did is I tried to like do a call out for each box, and I don't attend the OCP CPU debug meeting anymore, but they're looking at things like how do you unlock a CPU to do, scan dumps and trace dumps and stuff. So I can't speak to that anymore. I'm not particularly involved like I used to be. Fleet memory, we did the DDR5 error logging requirements, and when I pasted the name of the white paper review, that was effectively what one of the reviews is. And we're going through a corrected memory error scenario right now. And then we'll look at what's next, whether it's HBM or LP error logging requirements or two candidates that people have discussed, and maybe there's some other ones too. But this is kind of where that group is.
Hey, Drew, I have a question about that. So I recently took a look at that document. So the formats that are listed there, are they already consistent with the CPER format that's in UEFI spec, or that's an extension?
No,
Like
and
you're
so
suggesting any extensions?
no, but I want to shout this from the mountaintop. The spec that's defined in CPER is a lowest common denominator. It is like if you do it, you're not really doing yourself any favors. And the problem is that different CPU vendors, as you well know, log the errors in CPER in different formats because they have different register sets. That's okay. The goal with FMFM is that somehow you log the things that we've listed, and then when you present them to the memory vendors for them to analyze them, you translate them into a intermediate format that is consistent. And so we're giving you flexibility to log them in hardware however you need to, but when you decode them and you build that vendor specific analyzer into your analyzer, you have a way to talk to it, and you've got to work that out with the memory vendors.
Mhm. But if you add the extensions as suggested in the document, say added new fill, so do you expect that to be, or like, was there any discussion about having that as a different section in the CPER, or is it, it can be just vendor specific, we can just extend it the way we like?
Yeah, because Intel, I know Intel's registers well, and I assure you, they're very different from, the ARM memory controllers and the AMD memory controllers. And so it's hard to get it's going to take a lot longer to get all and I'm not sure it's in our interest to get all the CPU vendors to use exactly the same registers. That doesn't smell right to me. And we want faster results. So log them the way you log them, but then decode them in a way that the memory vendors and the rest of us can use them. And so, but that's to be worked out with the memory vendor.
Let me chime in a little bit
Okay.
here, Drew and Shweta. So whatever UFI spec is defined, we're not influencing that. Right now, we're just leaving it as it is. And if someone just want to use that, we're not stopping that. What we're doing is we're enhancing, expanding the fault management coverage by defining the requirements in the log, and how it is implemented can be actually vendor specific implemented, as long as they provide the decoder to us. And to
Exactly.
us means to the hyperscaler.
Okay, sounds good. I mean, that's consistent with what we have been talking about from the analyzer perspective, right? Like vendor defined analyzer. So,
Right.
but I haven't been involved in FMFM, so I just took a look at the spec recently.
The thing is that CPER was defined, especially the type 16, I believe, I remember, was defined such a long time ago, and technology has moved on from there, right?
Right.
And it's very hard to scale and enhance that CPER format. And
Yeah,
by the time we
sense.
define it, new technology comes in, right? So it's like always catch up. So best thing, and I like Drew's thought process there. Let's keep it vendor specific as long as we get the analyzer decoder.
Yeah,
Developed by
makes
vendor.
sense. All right, and hi to Russ. Actually, Russ, I just saw you this meeting, so.
Hey, Shibata.
Yeah, what's
Hi
your role, Russ?
again.
Hey, Neil. So, sorry, Drew, do you want me to answer that? Do you want to keep
Oh
going?
no, yeah, please. And in fact,
Okay.
I kind of jumped into things while we were waiting for people to, and I should have done an introduction. So I'm sorry. Go for it. Sorry, Russ.
Yeah, no worries. So I joined OCP staff. So actually part of the foundation itself, not any specific company. Principal hardware engineer. My role, I'm working on kind of my R&R, but the way I see it is fundamentally my role is to help the community, you guys, get to spec quality, achieve your goals that you have in your projects and work streams, and then facilitate what I can when we need to understand kind of the workflows that are going on between the projects, et cetera. I'll be honest, I came in, start looking at spec templates, workflows, et cetera, and I see a lot of opportunities to simplify, make things a little bit more straightforward, easy to use. And I know just coming in from an outsider, I really wasn't kind of involved. While I had seen OCP work, I really was never a project lead, never active in meetings. So coming in very blank, I see a lot of work streams that overlap and people asking, well, who's doing what? So that's the basics there. I have to do a lot of content review. So
Welcome.
apparently every spec that comes through, I will review now.
Oh, wow.
So Russ, this is awesome. Are you attending every meeting or
Oh, no.
selectively?
There's way too many. Honestly, I'm trying to attend the project meetings. And then, you know, myself, I have certain interests. So I like to, I'm using project meetings to understand how people are working. And then, you know, as I have interest areas, I'm using that opportunity to attend those meetings. And hey, RAS has always been fun.
That's why I was poking into that. Good. Thank you. Thanks, Russ.
Yeah,
So your scope is like all of the hardware side, like your interest area is one, but like as a hardware engineer, would you be looking at server? I mean, what's the overall technical?
So my let me break it down like this. Spec quality, all specs. So not just hardware.
It's all over the place.
It's all over the place. And Shivadi, I've done BIOS in the past, long time ago, right? So I mean, I have some capabilities there. So spec wise, everything. Workflow, everything. I'm going to add this discipline, everything. And that's more discipline from how OCP operates. And to me, that equates to the simplify for the volunteer leads.
Yeah,
Yeah,
this is good.
Thank you.
This is good. I think your efforts will take our OCP to the next level. I can tell you that. I appreciate it.
Yeah, I see Russ also in another group, and he's been moderating occasionally when there's discrepancies or just trying to move things forward.
Good.
That's great. Yeah, thanks.
Thank you.
So, and then do we have any other new folks? I think is V Sarada, is that Vilas? Or is that someone?
Yeah, that's me. That's me.
Okay. That's just a new name for you. And then,
Yeah.
okay, well, welcome. And then Vladimir, I think I've seen you in some meetings before. But welcome. We're glad to have you.
Yeah, thanks a lot. Thanks a lot, Drew, and thanks a lot, group. And Anil, you were the one who inspired me to actually join the group. I do what I can in my role. So currently, I'm a senior solutions architect. You know, a little bit further from the engineering, but still, I've been a long time with the OCP, and so trying to make the network stack a little bit more resilient. So coming from the NIC and DPU side, and also worked with the switches a lot. So currently, with my focus on NIC and DPU, there's a lot to learn, and yeah, this group is pretty interesting for me.
Cool.
Yeah. So thanks, everyone.
Well, I joke that if you want to learn how something works, learn how it breaks. So, that's up.
Welcome.
Yeah, welcome. Glad you could join us.
Drew,
Okay.
that's actually not a joke.
No, I know it's the truth. It's the truth. I've discovered there are parts of chips that I had no idea existed because they blew up on me. So anyway.
Yeah, anybody who wants to work on fault handling are the brave people, I can tell you.
I know.
Yeah.
They had a giant security conference at my site this week, an internal security conference, and there were all these people, and I was thinking, wow, there are not that many people brave enough to work on fault management.
Right.
But anyway, but we are the few, the brave, the fault management people. So welcome. Okay, so so back to this, and you know what I'm doing here is just trying to give an overview to give us a kind of a make sure that all the other work streams kind of fit together. And so RAS API right now is focused on, you know, proof of concept, error logging, and CPAD flows, and then we'll do discovery and configuration a little bit later. But we're trying to, like, you know, just get the basics to prove that we can do a round trip at scale, and where an error log, you know, gets collected, gets analyzed, and a message gets sent back to the system to do something about the error. Then here I've got a few proposals. I'm going to skip here and do this team last and go to the GPU RAS. They just updated their spec, and it contains information about debug dumps and crash dumps from GPUs. Uh, uh, expands on details. I should have said details of the spec. I don't know. Expanded details. And for some of the things like updates on, and there are updates on, you know, RAS features and error injection, error reporting, just where people had feedback, complaints, comments, or questions, and so we kind of cleaned some things up. So that's in the process of being released. Also, it's going to the hardware steering committee this month. So,
would there be an equivalent one for NVMEs?
No, and maybe that's a hole we want to consider. So I'll put, so let's, oh gosh, that's one thing I really don't like how this moves things when you bump them. Okay, so we talked about storage. I'm sorry, you were saying NVMEs?
Yeah, I was asking if like you have a group for CPU, another for GPU, same for the NICs, for example, you know, for the network.
Yeah, I don't, you know, we've not talked about, we've done more PCIe error handling. And so in this group, we just finished an update to the fault management requirements. The
Yep.
primary update was to add in-band logging at Meta's request.
Yep.
And then the other thing that we did is we looked briefly at a PCIe scenario, and I don't think we're done there, but Meta's gone. And there may be some CXL scenarios we want to consider. And then I'm doing some memory scenarios in FMFM, and so I thought they'd be worth bringing here. And our mentality is with some of these documents, like the scenarios, is to provide kind of a baseline understanding. Like a lot of people say, you had a corrected memory error, just, you know, count them, and, you know, when the average gets higher than something, then replace the DIM. Well, you could have a single stuck bit that you access 6 million times because
Right.
it's used frequently, and you might have, and that's not a bad error. That's like imminently correctable, not going to crash the system. You might have another system that has, you know, one error an hour across a whole range of bank addresses. And that's so far because it affects a large number of addresses, but the OS or applications don't access it often. It happened at a lower rate, but it was actually a far more serious problem. And so that's kind of what we're walking through on that scenario, is to just help people understand that you know, memory errors need some analysis. You have to look at patterns and addresses. And so we'll get that right in FMFM with the memory vendors, and then I'd like to review it here, and then we got to figure out how to publish the scenarios, and that way we can kind of have a rising tide that lifts all the boats, and we can help the memory vendors and help our silicon partners with a more informed user base. And that's kind of our goal, so that we do the right things and get the right answers. And then error injection is always a favorite topic, so I just added that because I know if I ask if anyone's interested in error injection, the answer is heck yeah.
Yes.
Yeah. Like it's just universally interesting to most people that work in this area. And then the next thing I put is, you know, just as a brainstorm, error handling and auxiliary silicon, so VRs, retimers, etc. NVMEs is a good topic, or, you know, and I'll say /NICs. And then I wrote a poison doc, and it's another kind of, just I wasn't trying to increase the state of the art. I was just trying to document how poison worked. And so that's been reviewed by a lot of folks here, and it's in the process of being published. But I was thinking we might want to review it here and answer questions and get more people that understand poison thoroughly, because every company I've worked at, I start talking to them about poison and then realize, oh crap, we've done something wrong. Like the really common thing is you consume poison and you assume that you've got a bad DIM and you replace the DIM at that address. And that may be the problem or it may not. And so the poison document walks through how to analyze poison and how to decide what to do about it and some software choices for handling it. So that might be worth reviewing here. But this is kind of, I'm kicking off the brainstorming now. So there's a ton to cover, but are there other high level topics that people?
Yeah, I have another one.
for
It may be already in one of these circles, but the same way that you have, for example, coherency fabric as a generic term on the CPUs, you also have a custom interconnect between the GPUs, what we call the scale-up network, right? Is that captured in that OCP GP RAS, or would that be another document or a section?
So the network, the GPU network, we call it X-Link in the doc. But NVLink is an example
Correct.
of one of those, and it is covered. Is it covered sufficiently? I don't know. And so what we probably ought to do there is that doc will be released in the next month or so, however long it takes to get through the review process. When it's released, we'll announce it here. And what we could do is, if you could take a look at it, we could get feedback from folks and then figure out what's next. And if it's insufficiently covered, then we can surface that and then work across the teams to find a home for any work that's needed.
Thanks.
But yeah, we're definitely open to your feedback there, Joshua. So
Drew, this NVMe, there is quite a bit of efforts going on outside of OCP. And I think some contributions were done in OCP also in a storage sub project, probably. I don't know exactly which project it is. Basically expanding the smart. I know Meta has contributed quite a bit, and it has become a part of some stack somewhere. So I think we should just kind of align with that and see if there's any additional information we want to communicate here as a part of scenario.
yeah, and I'm kind of listing brainstormed thoughts here. So that sounds, like I know a lot of these probably, maybe they're covered elsewhere and we just have to tie off with those groups and review what they did. I'm not saying these are all the topics we're going to cover. I'm saying, yeah, let's discuss them.
Right. I mean, anywhere there's a fault handling, right? But I mean, for that matter, every hardware has the fault handling, and it's good to kind of bucket them into the scenarios and tie the loose ends, leverage on whatever the work has already been done, and bring that thought process here. Same thing goes with Nick also. By the way, there's a lot of efforts already been made about on the Ethernet side of the errors. Link flapping and all that kind of cool technologies have been developed. How to monitor those.
Yeah, absolutely. And honestly, as a pain point goes, in my experience, NICs weren't the top of the list. There's good architecture there that isolates problems on the network from the host.
Right. I think one thing we want to call that out is like optical interconnect is another area where I mean, a lot of people who are working on optics do define the air handling. But
Mhm.
I don't know how robust it is. Is any
But you're
like
not thinking necessarily just from networking standpoint, but just connectivity between devices.
yeah. I mean, of course, optics is used for networking only. I mean, there's no other use case that I can
Yeah.
think of right now.
I mean, and like TSMC recently, publicly announced
Yes.
that they have EOL or E to L, on package, on die. So you have a chip package that has an optical pipe directly out of it.
Mhm.
Yeah,
Yes.
that's public. So it's coming, and we may need to think about it.
Right. Another area that somebody has called out and brought it to my attention was so the whole liquid cooling concepts are getting adopted in our data center and going to further grow, right? And the liquid cooling subsystems have their own interesting failure modes. How do they tie with the rest of the system fault monitoring and remediation?
Yeah,
Is
I've actually been looking at that the last few weeks, also. So that is a good topic. And we may need to bring thermal people in, but the way I look at it is, we're going to have errors on parts, and they might be related to a cooling problem. And so there has to be some connection between what's going on thermally.
Yeah, like a thermal throttling.
And what's going on with air as well. And it could, but like when I looked at errors at scale in the past, the temperature affected error rates in ways that sometimes surprised me. So, like understanding that relationship and being able to correlate it to what's going on with liquid cooling. So if you get a clogged, you know, uh, uh, pipe, or you have a leak and a pressure drop, or some other weird thing, some fluid contamination causes a increased pressure differential between the inlet and outlet of the cold plate. There's weird stuff that happens there, and the cooling people will take care of the health of the cooling system and does it cool adequately. But I think there are a whole host of second order effects that we see that we need to correlate to what's happening in the cooling system.
Yeah, basically, how do we monitor those events or errors, whatever you call that, right? And then tie with the rest of the subsystem or system error handling.
Yeah.
Right. I mean, one discussion I had was, I think right now the team is defining like a small leak and large leak. Now, what does it really mean? Right?
It means that it spills to the next server.
So yeah, I mean,
that's the big leak.
Pretty much.
Right. And the response time, there are a lot of assumptions being made, and then how do we, at the large fleet level, right? How do we bring that information and triangulate that with the rest of the fleet fault reporting, right? That thought process, I think, is still missing when I talk to at least the liquid cooling thermal engineers, right? They
I think this is really an interesting thing, Neil, because we have work that I think is directly, it fits nicely here, but it also fits nicely in some cooling group. And so these are good topics because I think we make assumptions about what the other group's doing, and there ends up being white space.
It's a complicated topic because it relates multiple things. There is the leakage of the current, there is the ambient temperature, and then there's the voltage and frequencies that you can hit. All of those things are tightly tied up. And then because you have, at least on the CPUs, you have this dynamic control. It's very difficult, and it's proprietary of every chip vendor. It's difficult to model what should be the reaction, but because it's going to be very chip vendor specific. Usually, when you're trying to simplify things, what we end up doing is fixing frequencies, for example, and because of the different binning, you end up having different power consumptions and therefore different thermal reactions at each of those individual chips. So it's complicated actually. There's a high variability even within a bin of more than say 10%.
Yeah, because complicated. That's why it is here. We should. This is a thing, right? We should brainstorm that. Yeah.
Okay. Yeah, it's a good topic. So and that's what I'm doing. You know, I'm just trying, and I'll send this picture out afterwards.
There's also another comment I'd like to make on the NVMEs. I don't know if other devices are also hot pluggable, but that can also, it's a feature that you have, you know, for serviceability. But if it's not done right, then it also triggers its own errors.
Yeah.
Yeah, yeah.
Well,
So NVMe hot plug is a very mature technology now. DPC is underlying technology we use to achieve that.
Yeah.
And that requires a white paper. Yeah, I mean, I'll be happy to write that. There's a lot of recommendations out there, but
Well, and Anil, while you were out, Meeta gave a scenario. We walked through a scenario that was based on her emails with you.
Yeah. Okay. Good.
Scenario, and I'll just say Meeta scenario because we'll pick that back up comes back. But then the other thing is, I think you know, normalizing DPC. You know, and like you know, we can have some software DPC discussions.
Yeah, I mean, PCI is subsystem, right? There are so many scenarios we can write. By the way, one scenario I will be presenting in OCP is how do we handle the CTOs? It's not easy. CTO
You
is
said
not
you completed timeouts. That's what you're doing.
Yeah, because you know, the CTOs also reports is not the culprit, right? So the information we get is, hey, I saw it, but that's not sufficient to understand what happened, what action we can take from there.
Yeah.
So how do we triangulate that to actual action, right? Is requires further analysis.
Okay.
So poison TLP, like egress versus ingress, right? That is also pretty interesting, and I think it ties with your poison as well as PCI scenarios. And what do we do, right? What would be the recommendation in terms of severity of the two error types, and should we enable it, disable it? There's so many aspects of that should be talked about in the scenarios.
So what I proposed there is like, well, if we're going to do that, let's start with the poison, like the overall big picture with poison, and I included you know poison TLP handling to some degree, but then what we can do is we can figure out whatever's missing in the doc and then spin off a scenario to cover any holes that we found.
Yeah, yeah. If this poison this document white paper is talking about that detail, that's fine.
Yeah. Yeah, I mean, it does at a high level, and it says, you know, if a PCIe device doesn't support poison, well, use DPC to, you know, contain the poison, stuff like that. But there are probably details that I didn't quite nail, and so, uh, but I think it would be helpful to have everyone on the same page with how poison works before we dive into the details of poison TLP. So maybe we do the big picture there, and then I think it'd be great. I think there's more work to be done. I just say let's do the big picture, then dive into the details next, if that's okay.
Yeah. If I take a step back, this is all good stuff that you're draw the bubbles here. There's another initiative going on in OCP. It's the resiliency, you know,
Oh gosh,
work group.
I forgot that. I just put that out of my mind, but you are absolutely right.
So I mean, the thing is that's kind of completely going parallel, but there is and I don't think there's anyone who really looking at the two together to make sure that you know there's no wherever there's overlap is being not conflicting.
So
You mean when even you have redundancy to offer resiliency, it still may not be enough, and therefore you have an error.
No, so let me clarify. They
a
call
terrible-
resiliency, but it's a silent data corruption or silent error work group. They're trying to define the tools to identify preemptively any kind of silent failures.
So Joshua, I bitterly complain when they named the group this. 'Cause
Okay.
They call it resiliency.
it's not resiliency. It's not resiliency by any.
It's silent errors. Okay.
Yeah.
Yeah.
Like I
Just
just
call it silent errors. What's the problem with that?
I mean, the problem is, the moment you say silent error, right? Then okay, so what do you do then? So I think they're defining, how do we indirectly detect those by running some testing the machine or components.
And Carlos is actually pretty involved in that group, so he's keeping me in sync. But
I'm participating. I've been
Yeah,
in it for
the last
years.
is there.
So yeah.
so I think I can put it as an overlapping circle, and I don't think there's any conflict. I mean, Vilas, do you want to give us a summary of what they're doing? I mean, is it okay? I put you on the
Yeah. No, it's fine. I would say it this way, right? I think the industry has realized that there is a SDC exposure across the industry. I think we've done enough work now to know that it's common to, multiple silicon vendors, multiple foundries, multiple whatever, right? And so fundamentally, the work is ongoing to try and align. Like, I think I would just say the work in that group has aligned us on the fact that it's a common problem and trying to align on common solutions, right? And so at the moment, I mean, I think there's been a lot of work, but a lot of it now is focused on, I would say, research into finding solutions, because I think it's generally acknowledged that there aren't easy solutions here, right? And so some research is needed, but across the board, right? So this is really, a joint effort on, silicon vendors and silicon consumers to go figure out the best way. So like periodic testing is one way, right? But there's like the work group's actually funding research, and some of it is on testing, some of it is on architecture, some of it is on design, so it's more broad than just testing.
got it. But it includes testing silicon to find SDC problems. So that's part of it.
That's part of it, yeah, right.
It's just a list of things that are going on in the group. So it seems like it's appropriate.
Yep.
It's one of the lists.
Yeah.
Yes, and then I also had to say that even from the memory side, memory vendors, we are putting special impetus on designing in solutions to minimize SDC. So when we do memory controllers, there are special solutions being put in, well thought of. So not only when we do SecDead or DecDead Reed Solomon codes, but lot into yeah.
So we probably ought to talk SecDead, when it comes to DRAM, has no place in the data center whatsoever. It is, like we need, broader symbol level correcting codes. And that's why bounded fault is so wonderful, right? Is that it allows us to correct bigger chunks of failures. And so DDR5 is pretty good. I mean, like bounded fault and the present chip kill like solutions for DDR5 are amazing. DDR5 transition has been the smoothest transition in memory technologies that I can remember, starting with DDR2. But LP LP is not pretty, and there's a lot of SDC potential there. So that would be a great FM topic, I think. and maybe we, bring it here some, but I think we have the memory vendors all there.
Absolutely, Drew, absolutely. And like I work on our CXL memory controllers. So out there, especially during the design-in phase, yeah, we certainly put in special impetus on catering to SDC.
Drew, while you're drawing these bubbles, I think since you're calling, I think your intention is to show the overlap, right?
Well,
So
I think that what I'm trying to show is that we've got a network of projects that all complement each other and have the right touch points. And I'm not like trying to scrub out the overlap, but if there is some, let's identify it. You know what, but I think we have a framework. This is awesome. We have like a very comprehensive framework of projects all tackling different aspects.
yeah, I mean, overlap is not in the sense that redundancy, overlap in the sense that how these two are tied together.
Yeah, there
right?
are definitely connections for sure.
Yeah, so in that overlapping portion of the circle, it'll be good to call that out. Like for example, OCP GPU RAS versus hardware fault management. Where is the tie there? There are certain things which are completely independent of hardware fault management that is defined there. And there are certain things which are either inspired from hardware fault management or expanded further from there.
I think what we'll have to do, I don't know how to fit it in this drawing because I'm running out of space, but yeah, it's fine. I think I'm just trying to show a picture of the different efforts, but I think it'd be good. Like we could talk about, maybe I'll put this on a few slides and have some slides that say, what are make sure that we have the appropriate tie-ins to the other groups. I'm not saying there's a big crisis though. I don't think there is. I think we got enough people in this group, in those other groups that, we're mostly in sync.
Yeah, I mean, it's important to maybe at some point define that so that in case some overlap, some redundancy happens, then we can find that out using this methodology.
So I have a quick question. So in this particular drawing, you're trying to take care of errors that are happening on systems that are primarily having CPUs and GPUs as the processing elements. So it's like a processing server for an appliance, so to speak, that it's for storage, where you still have CPU, memory. Even you could have an accelerator to do some processing of the storage. Would that be also in here, or is that a different document for like a storage type of servers?
So, I think that the owner of the creator of the appliance will have to figure out what they want to do. But my expectation is if they use DRAM and they want their server or their storage appliance to be reliable, they'll use best practices sufficient to make their appliance meet their customers' needs. And we'll have techniques, we'll have the RAS APIs is something that could certainly apply to that. And so that's one of the reasons Mita attends, because she works for Pure Storage and they do storage appliances. And so in my conversations with her, it's pretty clear that she wants to see what she can leverage of best practices into their products. But they may do things differently than a hyperscaler would, and that's fine. And so, like for instance, imagine a RAS API interface inside a storage appliance talking to a CPU. Getting memory errors or getting errors from drives or voltage regulator silicon, who knows what. So the RAS API might work for them, but they aren't going to have a data center infrastructure that they can just automatically, plumb all their appliances into because their appliance goes to a customer. And so they'll have to adapt the solution. And our goal here is, at least my goal is, I want to solve Microsoft's problems, but I want to do it in a way that solves so many problems for everyone else that when I ask silicon, suppliers to do what I'm asking them to do, they say, oh yeah, and this helps this market and this market and this people, and so many people line up with a common set of needs that they're willing to invest heavily in the solutions that we want for Microsoft. So in other words, by you winning, we win. It's kind of what I'm pushing.
Drew, is there any idea on the box on the lower right, the priority? I mean, is leak detection or optical or NVMe, where does that fit in the priority, or PCIe errors? I mean, they happen all the time. The priority that we want to address things in.
Yeah, they're pretty, PCIe errors are pretty hot. And so I think, that's what we need to do next is prioritize these. So I'll send this out and I would encourage people to consider what they want to do. The other thing that will be a forcing function for what we work on next is who's willing to help drive some things. And Anil, if you have something for CTOs, that might be a quick win for us, is to go through a CTO scenario, and then we can work on prioritizing all these other things and go from there. So there'll be low-hanging fruit and there'll be what's important to everyone as factors into this.
Drew, did you happen to see that at the Hot Chips conference on August 24th that they were a presentation was that there's going to be let's see, on the optical side, one QSFP error every 9 days in a big cluster?
Gosh, that infrequently?
Yeah.
Is that a pipe dream or this is the reality?
Like, that's pretty good.
Yeah.
Hey Drew, sorry, before we run out of time, two quick things. The port management is such a requirement 1.5. Is that all done now? Is anything left here? That means from our side.
Yeah, so that review is ongoing, and I'll share. I can share. Well, there's like minor feedback, like there's some places where we need to put a R with a circle for registered trademarks. But and then there's some formatting problems where like there's a heading and the paragraph starts on the next page. So there's minor stuff like that I've seen in the feedback. So Yogesh and I'll make the minor changes like that, and we'll let you know. But there's no substantial changes or suggestions yet from the reviewers.
Awesome, cool. Then the second topic is I will be presenting on the CTO in this global summit, and I would love to review it here and get the feedback. So if you want to queue up that for next week, I'll be happy to present that. 20 to 30 minutes.
Yeah, let's plan that. And then the other thing I would do is I'll send this picture out. And if you could think about what I'm suggesting, and think about where your pain points are, what the priorities are, and if you're a silicon provider, what are your customers complaining about a lot? If you can tell, I mean, if you want to guide us without giving any secrets away. But we'll do that next week. So we'll work on prioritizing this list, and we'll go over your CTO presentation. Does that sound good to folks?
Sounds good to me.
Well, thank you for your time today. And this is a little bit different meeting, but I just, I hope this was helpful. But I really want to make sure we have the big picture in mind and make sure that we have a kind of a cohesive view of how things fit together.
Hey, Drew, real quick.
Sure.
So your white papers, I am not privy to the work stream, so I can't actually see the status. Alicia has been traveling this week. I actually have a meeting with her early Monday morning, so I'll talk to her and make sure she gives you an update.
Okay, thank you. And it's not a crisis. I just want to make sure I'm on track and making progress. I don't know what I'm doing with the tool. So if I need to do something, it's not obvious. So if she tells me, I'll jump on it.
So actually the flows are new, and I'll tell you that we're I I've had discussions like this with others. So as we hear the feedback, we'll make modifications to the flows. But
Sounds
the whole, I want to make sure that I know I have an action and I'm not waiting for somebody, has been some feedback we've received.
okay. Yeah, yeah. I've had a few times where I've been a little confused about that. So, but okay. Thank you so much, Russ. That's awesome.
You bet.
Okay, well, why don't we end a couple minutes early today, but thank you so much, everyone. And if you have feedback on things and you just want to ping me privately, you have concerns, reach out. I'm always happy to chat.
All right. Have a great weekend.
Have a good weekend.
Okay, you too.
Thank you.
Okay, see y'all.
Okay, let's have some fun. What's next? Hey guys, you hear me?
Yeah.
Hey, would you take a look in the chat? Apparently AMD presented it. I'd like your opinion. And did you know what was presented?
Oh, hot chips.
Yeah, Joel, we're talking about something that was presented at Hot Chips.
Oh, okay, no, go on.
No, it's in the chat. I mean, I put it up early.
Oh, okay. Who was the presenter on that?
Darren Vallis. And there's another guy, Frank. Let me.
And Domes?
Yes, that's the name.
Yeah, I mean, I don't know if this is like, this looks kind of counter to our package optics plan, right?
Yeah, I'm just trying to figure it all out.
I forget the name of that couple at Meta who was championing optical backplanes for a while. Oh, the name escapes me. But they had an idea they were pushing about 10 years ago on co-packaged optics, and that's kind of how the Kobo removable modules started happening. Was because they couldn't deal with swapping out an entire card if your co-packaged optics and one of the lanes failed. So I'm wondering what kind of MTBF targets we'll need to hit in order not to be 9 days.
Right.
Installing one of them starts to fail, right?
And my question about this number is because to my knowledge, because I use the CIMS specification, and I only can look at failure rates at a percentage, like how long are you going to live? If you have a brand new installed system, maybe for the first year, there's no failures. And over the next 2, 3, and 4 failures or years, all the failures stack up then.
Right.
So I don't know what to do. I don't even know what to do with this number.
But isn't this, isn't this counter to our, like, the cost per unit bandwidth is probably much higher than the power, I would guess is much higher than.
This is why I like this group. I like questions like that. And Steve, I
have the entire presentation by any chance that we can share.
I can ask.
Who's the who made this slide?
I believe Darren Vallis. Okay. Or Frank. I don't know.
Because I find something very curious here on the OSFP, right? I mean, we know Google buys OSFPs from InnoLight, at least in the OSFP 28 gig NRZ generation. They buy them in the millions of units. So 5,000 OSFP shouldn't be it. Now, if you're looking at a million OSFP units deployed at Google, I don't think they only last 9 days before one came. So I actually question the math. I'm not sure about this 9 days. I don't think you could.
Joel, I'm just putting up what I see.
I know.
I like this group because they question things like this. I need to know what to do with the data to try and say, hey, what do we need to make good decisions real time when it's deployed?
It seems like this slide is trying to make a case against using optical SFPs, right?
Well, I don't even know.
These are not good numbers, I think.
That's why I wanted to see it, and I asked for the entire slides.
Right, I totally agree. And if this was presented, you guys, you're fellows, I'm not. If you're fellows, why don't you even know that something was presented at Hot Chips and you can't get the presentation?
I honestly, I checked out the repository that we have, and the hot chip was not there.
Okay. So you guys stand a better chance at getting the entire presentation than I do. When you get it, could you give it to me so I know something?
Of course. Sure.
For my part, I mean, I don't know whether we're starting the meeting or not. I know that Steve is running around doing vacation or something like that.
Okay, so we don't have Steven today.
I'm not going to say that. He runs his own schedule. But I will say that I had an action item from weeks ago to give you some information on OCP and optical. And as far as I can understand, there has been no specification, nothing. But I am not privy to everything that's going on. You know, they have these licensing agreements where you can disclose things. So not everything at OCP is public. We do have an AMD person who sits on the advisory committee, so not board of directors, advisory committee. And I have asked to talk to him because he must be able to filter what's going on as the official standards. Too many things happen at OCP, in my view, where two companies get together and they publish it under the OCP banner, and then you don't know if it's real or not. And I can say that from experience because for the first 3 years of OCP, I'm one of 5 editors of the OCP hardware management. And anybody could put anything they wanted there. And I think it has gotten worse. And now there's not only 5 people, there's probably 20.
Yeah, personally, having suffered under all the inconsistencies in the Wedge 100 switch design, I'll tell you, it's a little bit of a zoo.
It is a zoo. So when I say I don't want to, damage my own reputation by telling you guys, hey, there's nothing there. There might be something there, but I don't have visibility.
If you narrow the question, I can ask around an OCP community and ask them directly what's going on.
And I'm going to be at OCP. If any of you guys are out there, I'd love to have a beer with you or something.
Unfortunately, I have 2 presentations which I have to cancel it because of another conference that I have to attend. But I know people at OCP and I can ask them if we narrow down the question. I know there is activity that they are pushing us to have optical version of the die-to-die, but that's as far as I know.
Yeah.
And there is an optical type of PCIe that they are pushing. That's another activity, but other than these 2, I haven't heard. But as you said, it's a large organization and every 2 people can create a work group.
Right. Okay. I think zoo is a very good acronym.
It's like Noah's Ark. You only need 2, right?
Right. Guys, I'm on the receiving side. I mean, once everything optically is done and whatever, my side is to address the modules, get the data out, and the data being errors, priority or transmission levels, whatever, and try and report it out. And I'm trying to help you, but I don't see a spec that I can point to except the 5.3 spec.
Okay, so I think in general, OCP is not going to try and blaze new ground, replacing things that are already covered in an existing spec. My guess is they'll leverage something, but they'll always try to, how do I say this? There's probably some amount of activity in OCP, which is a parallel effort to the main standards body, which is trying to create traction in a different forum.
Mm-hmm.
Those are the ones that are impossible to track.
Right.
It's just you basically have to be in both standard bodies to piece together the story. The original and then the offshoot in OCP.
Right.
So maybe for Shahab's offer of help, is there anything specific, Hank, that you can think of that would help to phrase the question a little better about what we're interested in? Worst case, I can ask a general question and let's see what are the response I can get. Okay, sounds good. So maybe we'll give you the AI should have to report back and let us know what you find out in terms of what's all the optics activity going on in OCP. I think if we just have a topic list and people we can reach out to, that'd be a great start. Okay, I will try to create that list and get at least what's going on there. Awesome. Thanks so much.
And for me, all I'm looking about is the reporting ability that we need to do and any level of control of the optics that we would like, AMD would like.
So Hank, I can help answer your question a little bit because I spent a little bit of time in the QSFP 28 timeframe working on PSM4 modules for a couple of years and looking across multiple standards. I think the stuff you're looking for is all the page 0 stuff in a pluggable module, right? So you need all the DDM outputs, right? All the RX power, the resets, the TX inhibit, the CDR lock unlocks, all of those LOS, LOL, all of those in page 0. I think those are mandatory typically, so we'll probably need those.
Okay, that
requirement CMIS or MSA for QSFP-DD with.
That's good information. One of the other questions, I mean, to maybe look ahead, do we want this information available before the GPUs and CPUs are turned on? Because there's a level of debugging or a level of ensuring the network is intact and operating the way we want before we apply power, 1500 watts per GPU. Is there a time period we want to ensure that everything is ready for the GPUs to use when we actually go from 0 power to 1500 watts?
What does the system bring up sequence? Usually for optics, they are brought up.
Let me go get a picture. Just a second. Okay. And what I'm going to show you is controversial because people have not, within the DC out, so we're talking the module that turns on the entire tray. And what I'm going to show you, the module would work, or the sequence diagram or state diagram works with not only GPU trays, but also switch trays. It's going to take me a minute here, guys. And if you want access to the real-time information, I can go give you the actual AMD internal look at this. Where are we?
I wanted to ask a question. Is the scope of this meeting series, is it strictly focused on the product, like in the Camelot timeframe, or are you guys also going to be involved in designing the test board and or package infrastructure for the test chip of A0 silicon?
Sorry, I missed your other meeting, Rich. I think we should keep them separate. We'll keep the test board and package stuff in your meeting, and then this one will be more the software architecture. I actually prepared a hack-up version of Krishna's slides. After Hank is done, we can jump to that. I just wanted to reframe the meeting series so that we are all aligned on the goal. And then I also have a small blurb of what I'd like to see. Better if Stephen was here, but it's okay. We can talk about it and let him review the report.
Okay.
Because I feel like this meeting series is really about defining that management back channel. So non-mission mode, data traffic and bandwidth for control, right? The control plane of all of the OEs. And I think that, yes, it's focused on one product, but we're kind of doing the architecture for all future products. Since once you do one, I doubt we'll come up with a second version, unless if the first one really bombed.
Right.
they're most likely gonna carry it forward if it works, right? So let's just build a really nice one and build it scalable, and it should be good.
Can you guys see a black screen that says AMD confidential?
Yeah, nothing shared on my side yet.
Wow, why is...
Teams does that from time to time.
Yeah, let me work on
monitor
it.
setup, that might be one bug. But if you don't have a multi-monitor setup and it doesn't show, you might just want to leave the meeting and join back. After that, you'll be able to share.
Let me try that. I don't have multiple monitors at home.
You do or you don't?
I do not.
Oh, you do not? Okay, then maybe just leave the meeting and come back.
Okay.
Be here.
And
chat.
you know, that's probably quicker. Let me do that.
Because if you've already tried sharing it twice or 2 or 3 times and it doesn't show up,
No, and I already know chat works because I put that in.
Yeah. Sounds good. Let's do chat.
Okay, let me do this. And where's our... Okay, in chat should be a state diagram. Did it show up?
We do. No, I'm not seeing it.
Oh,
no.
Not here either.
Let me see what's going on.
You gotta hit the send button.
Really? I have done that so many times. Why isn't it?
I'm pretty sure Hank is hitting the send button. It's Teams. I'm quite adamant. I've had the same thing happen to me. You can even try quitting Teams.
Okay, I'm gonna quit Teams. I've put it in the chat twice.
It's a buggy piece of old thing.
Okay, I'm leaving Teams. I'll be right back. Oh. Crap.